Today I want to talk to you about large format 3D printing, which is actually a bit different from the typical desktop printing that most people might know and might be used to. So I'll jump into it quite quickly. Just a few words about BigRep. We're a company we exist since 2014, where we were founded in Berlin. Now we have sales representations in the US and also in Asia, like office in Boston and Berlin, with a headquarter in Berlin and a worldwide network of sales, resellers and sales representatives. What we offer is like the machines. You can see here one of our machines, the printers. We have 3 different types. On the left, we have the extruders. You get filaments, our BigRep filaments that we develop in cooperation with large partners, BASF being among them, of course, and you get software. Most importantly is that, as I already mentioned, large format 3D printing is quite challenging in some respects, and also prints take longer, it's more material involved, so the bigger you print, the more it's important to have reliable material that makes sure that your print is successful. There's nothing worse than having a 6-day, 7-day print that fails after 80% of the time. This is really annoying, and annoying is not even strong enough a word. So, talk to our customer service about that. So, first of all, what can you do with large format 3D printing? So, we have customers like Airflight in Denmark. They make large format drones, like people transport drones, heavy lifting drones. They do carbon fiber molds with our printers. We also have one of our customers that I like a lot is Canyon Bikes. They do the prototyping for the bicycle frames on the printers. These frames will get sanded and coated and painted. It looks like the real thing. The idea is to be able to present a new frame geometry to customers, to resellers, to see, is this still is this still the real brand? Is it still the shape that customers identify with a Canyon bike? Then, of course, we have this is a customer in the US. It's Nikola. They make electric trucks, and they do a lot of prototyping for fitting trials, assembly trials. Is it possible to? This is a part of the front of the truck. Is it possible to attach lights and other add-ons to this part? Because this is something it's really difficult to impossible to simulate. Then, of course, design studies. This is actually something that we made. A colleague of ours designed this electric motorbike. This is actually a drivable motorbike with, except for the electric parts, is fully printed, including the airless tires, which is TPU tires, of course, thanks BASF. And this is something that we have quite a few very, very successful customers. Large format sand casting. There's customers who make sand molds or models out of this, patterns, make sand molds, and then make metal parts out of this. This is, for example, this is a ship's propeller. We have quite a few customers from this area, but also, for example, a customer in Australia who makes church bells. So instead of making it the old-fashioned way with a clay model and everything, they simulate the bell in the computer, make a model, print it, and make a bell out of it by bronze casting. So, as you see, the variety of applications is quite huge. Then, of course, as I mentioned, large format 3D printing, you need reliable materials, and in our case, that means we can basically, with our machines, you can use all the usual suspects that are out there on the market that you need to know, like PLA, water-soluble BDOH, PLX, high temp. These are all our BigRep materials. It's carbon-filled materials, carbon-filled nylon, so everything is there. Engineering-grade materials, carbon-filled, temperature-resistant. So whatever you want to have, you can get it. As I said, here the reliability of the material plays a much more important role, in my opinion, because a 5-hour print, you can easily repeat that. 5-day print, somebody's stepping on your toes for that. But today, as we're here at the BASF booth, I'd like to put an emphasis on TPU parts. As we found out, or as most people will know, TPU has quite a few unique properties. One of this is the flexibility and the chemical resistance. So one use of TPU in large format 3D printing is gaskets. So I have one here. If you want, you can have a look at it later. It's robust, It's flexible, and we have a demonstrator here. So in case you have, for example, a housing and you need a cover on that, you can print your gasket instead of ordering it somewhere and waiting for 6 weeks or 8 weeks and then have that stuck in the Suez Canal. So, as I said, unique properties of TPU, very helpful here. Second, something like soft jaws. Very often you have parts that need a special careful treatment, but you still want them to be fixed in a measurement machine or a manufacturing machine. So you can have a part like this, which is really strangely shaped. Try to put that into a vise, very, very difficult. But you can create soft jaws, very sturdy, very rough, tough enough to keep the material, the parts in place, but still soft enough not to damage the surface. And and one thing we're really proud of here is software that we have developed. It's called Flow. I'll go into more detail with the next part I'm going to show you, because this is where the huge benefit of the combination of Flow and TPU comes into play. So what we have here is a transport inlay. You see it here, massive part, very, very cool, very strong. Actually, I can lift it with my hand. And what we did here, and you see that on the right, this is actually a hydraulic cylinder, and it's quite heavy. I think it's 30 kilograms something. And if you want to transport that and you want to have it in a box, you want it to be safe, not to roll around, not to be damaged, not to smash into each other. But you also don't want to spend a day designing a box for that or making this out of wood. And here, what we designed or what we made is a software called Flow. You just upload the part, the 3D file, and then this software creates this inlay for you. So you say, okay, this is the outer dimension. I want to have 2 of those oriented like this, and then at the click of a button, this inlay is created. This is the huge advantage of a software that lets you automate these processes, because to be honest, I know of no customer who wants to spend one full working day on creating something like this, especially not if we're talking about low part counts. So if you have like 5 identical parts, you don't want to create a box with 1 day of work, because that's too expensive. So again, TPU, strong material but still soft, has a cushioning effect, keeps 30 kilogram heavy parts in place and still soft enough. If you drop it, the part will not be damaged. So as I said, we have quite a few materials, but this is today I wanted to show you what we have in TPU, what the possibilities of TPU are, because this is a material that has a lot of possibilities and a lot of really, really good and useful applications. And yeah, please feel free to come look at the parts, take them into the hand, see. I mean, I'm always quite happy if I can do this with a part without breaking it. It's a 3D printed part that you can play around with it. So yeah, and if you have more questions, please feel free to come and ask later. So, thank you very much.